So what we're going to do now in this video is we're going to look at a hypothesis testing for the mean, and this is in fact a t-test, and it's going to be p-value and the critical value method. So we're going to do both methods just to show you that they're both the same and to review both methods. All right, so suppose that you wanted to show that the average GPA for SAC students is greater than it was 3 years ago when it was 2.5. You collect a random sample of 125 students and find that a sample mean of 2.65 and a standard deviation of 0.83. Use this information to conduct a hypothesis test at the 0.01 significance level. Using technology, we find the following printout. One sample mean T summary, we have the mean, or H0 or HA, right? You can see mu equals 2.5, right? That's the 3 years ago amount, that's what we know. And then we have it's greater than 2.5 because that's our alternative, okay? It says you want to show that the average GPA for SAC students is greater than it was 3 years ago, so your alternative is going to be the greater than. Then we get this information, we're going to get, here's for mu, right, because that's what we're testing for, our sample mean of 2.65, our standard error of 0.074, the number of degrees of freedom, because it's a t-test, right, our t-stat 2.0205, and our p-value of 0.0227, okay? So that's the information. Take a moment to just look at it, because this is really important. Can we utilize this information? So using our p-value method, we're going to be looking for a significance level, that is 0.01. Okay, that's my alpha. And I've got my p-value here, which is this one, which is 0.0227. If I look here, p is actually greater than alpha, so I'm going to fail to reject the null hypothesis. We'll get to writing our conclusion in just a moment, but there's the decision making for you. Hot diggity. Basically, right, p, the probability of getting our sample mean of 2.65 is it has a greater chance or a greater likelihood than 0.01, okay? So given that our mean was actually 2.5. So we don't actually have evidence to suggest that it's gotten better. We're just going to continue to believe that it's basically 2.5, right? Notice that we're not, just because we have a sample mean that's somewhat bigger than 2.5, it doesn't mean that we have statistical evidence that it's actually bigger than 2.65. It's got to be much bigger, okay? It's got to be statistically unlikely, all right? And so since p is greater than alpha, we fail to reject. Now let's talk about our critical value method. In our critical value method, I went in and I used technology to find a t alpha, my critical value, of 2.3568. And if we go up here to our printout, we can see that the t-stat is 2.0205. So t is equal to 2.0205. Now, when I go in and I construct my distribution to kind of give me an idea of what this looks like, okay, there's that, okay, I'm going to have 2.5 right here, okay, and notice that we're going to have the greater than. Here's my t alpha, right? My t alpha is equal to 2.3568, okay? In fact, it's probably even farther over, but my t, right, so here's my t value, t is equal to 2.0205. Notice that t is not in the critical region, right? It's not past t alpha. T is not greater than t alpha. And so consequently, since t is not in the critical region and t is not greater than t alpha, we have that we're going to fail to reject the null hypothesis. So now I'm going to write my conclusion. My conclusion states there is sufficient evidence. There is not sufficient evidence to reject the claim that SAC student GPA is 2.5. That's it. So what did we do? In the p-value method, we compared p to alpha. And since p was greater than alpha, we failed to reject the null. In the critical value method, we had our critical value t alpha 2.3568, and we have t, right, our test statistic 2.025. The t alpha, right, was farther over on the distribution. Okay, it's the cutoff for our critical region, and we notice that t was actually less than 2.3568, and so consequently it's not in the critical region, and that tells me that I'm going to fail to reject the null. And there's our decision.